Hello, and welcome to today's Tech Tuesday workshop titled Using Terraform to Provision Your Own Cloud-Based Remote Browsing Workstation. My name is Mike Pilkington of SANS, and I'll be moderating today's workshop. Today's featured speaker is Ken Hartman, SANS certified instructor and course author. So with that, I'd like to hand the workshop over to Ken.
Great. Thank you, Mike. It is a pleasure to be here, and I've been working hard, so I'm delighted to share what I have to present to you today. So a little bit more about me. I teach the SANS Cloud Security Architecture and Operations course that's known as SANS SEC 545. I've also helped develop the SEC 488 Cloud Security Essentials class. And in that class, we use Terraform, but we really don't have the opportunity to delve deep into it like we will be today. So with that, I want to point out that our content for today will be found on my GitHub repository. So let me just paste that into the Slack channel. And it's simply called Terraform Cloud Workstation. During the course of our session today, we're going to be making another Git repository. So you'll be flipping back and forth. And by the way, the slides for today's content, even though I have a short link for you, they're also available at this Git repo as well. So let me show you that. So if I switch over to my web browser here and pop into github.com, if I go up to the top level, here is our project that we'll be working from. The slides are in this directory, and then the workbook that we'll be working from, there's 15 different steps. We should be able to get through most of those today. Possibly we won't get through 15, which is really just testing and debugging, but we'll see how things flow today. So that is the layout of our course workbook that we'll be covering today. Of course, as far as prerequisites, we assume that you have an AWS account. We also have assumed that you're comfortable with launching an EC2 instance. As part of the preparatory materials, we provided you a getting started with EC2 tutorial. Our learning objectives for today. We're going to understand the various use cases for a temporary cloud workstation. And we're going to use Terraform to provision that in AWS. And as we build out the script progressively, we're going to be submitting those changes into our Git repo, a Git repo that you will make as well. And because we don't want to just launch a basic EC2 instance, we're going to pass in what is called user data into the EC2 instance so that it will run that configuration script during its first boot. And then so that we don't run afoul of AWS or, God forbid, the law, we're going to talk about the privacy and security implications as we wrap it up. So I'm going to start off by demoing the system that we will be building in our class today, and then we'll take it from there. And we'll be adding documentation as at the end, and then doing kind of a wrap up. Okay, so first I wanted to show you what it is, what it looks like that we'll be building. So here is a remote desktop session, and let me log into it because it's been idle for a few minutes. And this is Ubuntu that's running XRDP, so we can log into it using RDP. Oh, and by the way, if you're a Mac user, hopefully you got our message about having a RDP client installed so that you'd be ready to go for today's session as well. And then we can see that it has Chrome and Firefox, so choose your favorite browser, and it works just like you would expect. And then we also have, I've set up a shortcut for a terminal and installed Python. Yeah, so you can see that. So that is what we're going to be creating. I'm going to close this RDP session. Okay, so why would we want a remote browsing workstation? Come on, you probably have been attempted at one point or another to visit a website that you think is quite likely malicious. it's like, it kind of reminds me of that Geico commercial where there's the two raccoons and one's like, ew, taste this. This is terrible, taste this, right? So there's a morbid part of us that just kind of wants to see, so what really happens if I participate in this drive-by watering hole attack or whatever? So there's also times where we want to perform research without it being tied back to us. And it can be tied back to us with things like browser syncing. I actually like browser syncing, but I only want my browser to sync with my phone and with my two desktops when I want it to. We can also get cookies and be geolocated by our IP address and so forth. There's also browser fingerprinting technology where they can tell who you are if you're a return visitor or whatever based on the fingerprints of your browser, such as which plugins you have, your operating system, user agent screen, and so forth. There's other times where we might want to circumvent geolocation restrictions, right? So, for example, sometimes you can only do things if you're inside the US or inside certain areas of the EU. You might even need to pen test your perimeter, but you're inside it. So this would be another way. And sometimes you just want to try something, but you don't want to corrupt your primary workstation. So many of the same reasons that we would use a virtual machine, we can use a remote browsing workstation. And just because I installed Chrome and Firefox on it doesn't mean that that's what you have to do. You can install any other software on it you want. So what we're going to do is we're going to use our AWS account and we're going to take advantage of a brand new feature in AWS called Cloud Shell. And what's interesting to me is Google Cloud Platform and Azure, they've had Cloud Shell for a while, but AWS just recently introduced Cloud Shell as part of, I think it was their last reInvent. We're going to verify that Git is installed, and then because Terraform is not installed, we're going to install it. So we're now at step one of the workshop where we're going to install Cloud Shell together. So what you'll do is you'll go back to the GitHub project and we're going to go to step one of the markdown, and we're going to do that. So first I will demo it to you, and then I'll give you a little bit of time to complete the step one. So I'm going to switch over to my browser again and then click on step one. So first of all, we have to navigate to Cloud Shell. So I'm logged into my AWS account, and we can launch Cloud Shell by clicking on this little guy, that little icon up there by our name. And it may take a moment. Notice it opens up a brand new window, so that way we can still get back to our console. And while that's booting up, let's take a look at what we're going to do here. We're going to do which Git and then which Terraform. And the which command tells us where that executable is installed. And then if you're going to install this on a normal Amazon Linux system, you would run these commands. But the problem that I learned when I was testing is that with this Cloud Shell, if the executable is not installed in the home directory, it won't persist when Cloud Shell closes. So what we're going to do is we're going to install it locally. By the way, I have the hyperlink of how to install Terraform if you need to install Terraform on any of your other systems. Okay, Cloud Shell is probably getting pretty close to run. All right, while it's still, you might want to go ahead and open Cloud Shell right now. Let's go to this tutorial for opening or for installing Terraform. Terraform has tremendous documentation. So what I'm doing is the manual installation of the precompiled binary, and then I pretty much just brought all the commands together. Okay, there it is. So here is so I can go like, who am I, right? And I'm logged in as the Cloud Shell user. All right, so now I've copied the commands down here, and we're going to just paste those into the Cloud Shell. Oh, no, first we wanted to do which Git. There's our path to Git, and then which Terraform. And we can see that Terraform is not installed, so that's why we're going to install it. So we're downloading it, and then it was downloaded as a zip. We unzipped it, moved it into a directory, and then I'm just removing the zip file. All right, so now if we go ls, we can see that it's in, or that we now have a bin file, and we can go ls bin, and there's our Terraform file. And if I up arrow a bunch of times, I can see my which Terraform, and there's this path. So now we have Terraform installed, and I think that was it for that instruction. So go ahead and do step 1. And by the way, at the end of every step, I also have a video if you get stuck, because we have 170 some folks online, so we may not be able to give you direct hand holding, but hopefully by watching the video, you'll be able to get. Okay, the next thing that we're going to do is create a GitHub account if you don't have it. Many of you may, and in that case, just log into your GitHub account. So I'm going to switch over to step 2. And essentially what you do is you open up a browser tab to GitHub. Now I'm already logged into GitHub, so I'm going to open up an incognito window. So if you've not signed up with GitHub before, you just click on the sign up, provide your username that you want and your email address, and then you got to solve this silly CAPTCHA. And then when you get all the fields filled out, then this create account will be enabled. Okay, so we're going to keep moving just because the fun stuff is yet to come. All right, our next step is we're going to create a GitHub repository. So if you go to step 3 in your workbook, that will give you the recommendations. You can pretty much just copy and paste the names that I've suggested. So go up a step and then down to step 3. So what I'm going to do, and you might want to do this as well, I'm going to right click here and I'm going to go open a link in a new tab. That allows me to keep the one that we're following along, so I can come over here and create a new one. Then I'm going to click plus and then choose new repository. Okay, and then what am I going to put in here? Well, I'm just going to use the suggestions in this step. So the name of this other Git repository is going to be called Tech Tuesday Cloud Workstation. I'm going to paste that guy in there. And then I'm going to leave it private for now. I'm going to add a README, and then I'm going to say create repository. Oh, I put my name in my description, skipped a field. So they're putting my name in, and then I'm going to use the cloud or the description from right here. Tech Tuesday use TF to create a cloud workstation. There we go. Now I have all the fields provided, and now it will create. Okay, the next thing that we're going to do is we're going to git clone this into our Cloud Shell. So here's our Cloud Shell. I'm going to type clear just to clear it off. And then I'm going to click code, and then this little clipboard to the right. So I'm going to copy that, and then I type git clone, and then paste that link in there. And that link should look like this. Now, you're going to have to provide the credentials that you used for your GitHub. So that's my username, and then I got to copy from another location my GitHub token. You might just need to use a password, but I have multi-factor authentication set up on my Git repository. Okay, so now when I type ls, I'll see that I have another directory called Tech Tuesday. So cd, type the word TECH, and then tab, and we're now in that Tech Tuesday directory. Then if I type ls, we can see the README file, but the README file really just looks like this. It'll have the name and then the description in there. Step 14, we're going to go back and modify that. Okay, the next thing we're going to do is we're going to create a CLI profile. And technically, you don't need a profile created on Cloud Shell because you can run the commands because you're already logged into AWS to even be able to access the Cloud Shell. But I want this project, and I want you to understand how to do this, even if you're running it, say, on your Linux box or your Mac. So the steps to create a CLI profile are particularly relevant if you're not working in Cloud Shell. However, we're going to use the AWS configure command, and that's going to result in a file called credentials getting stored on your Cloud Shell. Cloud Shell can only be accessed by your web console, so it's reasonably secure. But I can tell you, if you put it on an EC2 instance, that EC2 instance gets popped, then somebody will have access to your entire cloud account. So you would never want to do that. And this is some of the stuff that we cover in the SANS Cloud Curriculum courses. Okay, so to create a AWS CLI profile, we're going to go over to step 4 in the workbook. So step 4. Here are the important notes. I'm just giving you those same warnings again. So what we're going to do is we're going to go into the console and we're going to create a user. So we're going to click on the IAM service. You can also find it up here. So IAM, click on the service that it finds. All right, and then click on users. We're going to add a user called Tech Tuesday. We're going to give the user programmatic access only. Then next, attach permissions directly. And then we're going to say administrator access. Yes, we're given this way too many permissions, and we'll dial in the permissions, in the future. So what we're trying to now is just make a simple lab that's easy to follow. Next, review, and then create user. The next thing that I want to do is pop up Notepad. You can download the CSV file, but I like to not even have a file saved with my access key and secret access key. So I'm going to copy the first part, and then I'm going to type paste. Over here, I'm going to click show. And I'm going to copy this, hit paste. And then I'm going to hit close. Now I've disabled my access key so that none of you hackers out there can pop my account. Okay, the next thing that we're going to do is we're going to use this information that we've copied into our clipboard. Notice I didn't save it, so I don't have any file remnants on my computer other than possibly in the paging of the OS. Okay, so we're going to run AWS configure, and we're going to pass in the name of a profile. And the AWS configure command will ask 4 different questions. The first question is, well, what is your access key ID? The next question is, well, what is the secret material? And then our default region. Up here, you need to make sure that your default region is whatever region you've been using. It could be US East 1 like me, but nowadays AWS tends to default people to US East 2. So whatever is appropriate, and you have to spell it exactly US East -1 as an example, all lowercase. And then our default output will be JSON. Okay, so now, now that you've seen me set that up, I'm going to run a command that's going to rotate my access key so that I'll be able to run commands. You won't have to do this particular step unless you show somebody your access key. Okay, so now I should be able to do a command. Oh, I'll tell you where to get the command. What we're going to do is we're going to do STS caller identity. STS get caller identity. This is an AWS CLI command. And this says whose permissions were used to make the call, and it says Ken Master. Oh, that's how I'm logged in. And so that isn't what we expected. And the reason why it isn't what we expected is because we have to type the profile that we want to use. Okay, so now we're doing things as Tech Tuesday when we run a command with the profile my Terraform in there. The next thing that we're going to do is we're going to create an SSH key pair. And that is step 5 in the workbook. Okay, so what we're going to do is we're going to run this command, AWS EC2 create key pair. And guess what that does? It creates a key pair. This is how we're going to SSH into the workstation that we're about to create. We're going to give it a name of Cloud Workstation, and then we're going to query for just the key material portion of the JSON output. Then we're going to redirect it into a file called cloudworkstation.pem in our home directory. So copy this command. And then we paste that into our Cloud Shell as well. Okay, and then now we can see that we've created this file by using the ls command. But we see the permissions are wrong, so we have to do chmod 400 to set the permissions right. So let's run that command. And then if we up arrow twice to rerun the ls als command, we'll see that it's now read only by the owner. Okay, great. So now we've got our permissions right. Have you taken a look at what that command looks like? Let's do that. We're going to look at it by just using the cat command. And you'll see something that starts with begin RSA and then end RSA. So what I'm going to recommend that you do is you copy this off of your Cloud Shell. Copy that and then put that into your handy dandy text file. We don't need these anymore, so I'm going to blow them away. Right, so again, since I've showed you what my key is, I'm going to run a command to rotate the key. This is some command line kung fu. Okay, and by the way, if you want to see what these commands look like, because you're probably all geeks like me, I'll show you where I put them. I put them in Cloud Workstation, and then I have a thing in here called MISCs, one called CLI Command Line Kung Fu. So these are just for my benefit while I'm teaching. But since you're probably wondering what it is that I'm running, I thought I would show you where I put those for my reference. All right, so we're currently on step 5, so got to go back and take a look at where I was. Workbook, step 5. All right, so I've rotated my credential, and now we're good to go. So we've now got our SSH key pair created. Good. Now the next thing that we're going to do is we're going to create a TF-vars file. And what is a TF-vars file, you may be asking? I'm glad you asked, because now I can explain to you. So Terraform as infrastructure as code sometimes will want to pass it different information. So that when the script runs, we can customize it to our environment. So for example, if we want to deploy the resources to US East 1 versus US East 2 or US West 1 versus US West 2, we might want to pass that in from the command line. We could also do it via environment variables that are set on the particular server where we're running the Terraform command from. And then the third option is to use a tf-vars file. We can name our tf-vars file anything as long as it has the tf-vars extension, and you can even have multiple tf-vars files. If you do have multiple, they will all be processed. And our main code is going to be in a .tf. So what is the difference between a .tf and a tf-vars? Well, we will set the variables in the tf-vars, and then we're going to declare the variables so that we can use them in the .tf. And you'll see this here in a moment. All right, so now we're on step 6. So let's bop over to our workbook again. Got to make sure I'm in the right one, the Terraform Cloud Workstation. So go into Workbook, step 6. We're going to be using Vim. Now, in many of the SANS classes, we'll use Nano, but I'm like, well, let's use Vim just because it's a powerful tool, and once you get used to it, you'll like it. You may even prefer it over Nano like I do. So I'm going to copy this. Now, we want to make sure we're in our CD, we're in the right directory. So I'm going to type clear. And if ever you want to make sure you're in the directory, you just go CD, and then you go ~/TECH and then tab. And that the tab does auto completion. So I'm still in the right directory. Now the next thing that we're going to do is we're going to run Vim. We're going to run Vim, and we're going to create a file called terraform.tf-vars. Okay, now to put it into insert mode, you hit the I key. And then we're going to come over here, and we're going to copy this code. Copy, and then pop over to Cloud Shell and hit paste. I always like to add an extra character return or carriage return. And then now you hit escape to get out of insert mode, colon, and then W to write it, and Q to quit. So colon WQ. And now we have that file. I can even go cat and then that way you can verify that you wrote your contents. Okay, so that was all there was to step 6. We're building here. Okay, good. Now we're ready to do our first Git commit. Before we do that, I want to explain some of the most frequent Git commands. The git clone, we've already used that, right? That was to copy a remote repository and make it local. I like to use the git status command liberally because that lets me know the status of the files. Are they staged for commit or not? The git add command selects specific files to be included in the git commit. The git commit is what records the changes to your local repository, whereas the git push, it pushes them up to a remote repository. You'll get to see all these. And again, if you're brand new to Git, what I would recommend is you do a tutorial. Here's a good tutorial recommended by GitHub. It's just the hello world, but there's lots of great learning as part of that. Okay, so we're now going to do 7 in our workbook. Okay, first thing we have to do is we have to configure Git. So what I'm going to recommend you do is you don't copy the part of the line in quotes. You copy just the first half. That way you can provide your email in quotes. So I'm going to type clear to bring it up to the top of the screen. Okay, so I'm going to paste that. And then in quotes, I'm going to put my email address. You put your email address. And you can feel free to email me at that. Just introduce yourself as a SAN student or somebody who took the Tech Tuesday workshop. That way I can differentiate you from a spammer. All right, the next thing that we're going to do is we're going to do another git config command and set our username. Now our username is our spelled out name. It isn't our user ID. So I'm going to use my search engine optimized version of my name, which is Kenneth G. Hartman. Although my friends and colleagues just call me Kev. Okay, so we've got our basic configurations for Git done. Now the next thing let's do is take a look at the files we got going on. We're just going to type ls. ls, and we can see that we have two files, right? That README, which is already up on our Git repo, and a brand new Terraform.tfrs. If we type git status, we'll see that we have an untracked file called Terraform.tfrs. So the next thing that we're going to do is we're going to do a git add, but we need to tell it which file that we're going to add. So what I like to do is use tab completion. So we're going to type git add and then hit tab. Git add ter and then tab, and then there we go. Now if we up arrow twice, we can rerun git status, and we can see that it's now a change ready to be committed. So let's commit it. There's a shortcut when you're running git commit is you use the -m switch, and then you can provide a commit message. If you don't use the -m switch, then you have to do it as a separate step. So for us, we're going to be efficient. We're just going to copy my recommended git commit message. Great. So now it's in our local repo. The next thing that we need to do is push it up to our remote repo. So we're going to go git push origin main. And this only has one branch, so we're going to just continue to work with the main branch. Now it's asking for our username and password. And then it asks for my password, which I got to get. Okay, when it's done, we should be able to pop over to our Tech Tuesday, and then when we hit refresh, we should see a brand new file. So I'm going to hit refresh, and there is that new file, and it even has the git commit message. I can click here and see the change, right? So all the stuff in green is new. So it'll show you line by line the edits you made to a particular file. That is an awesome thing about using Git. Okay, so from here, now that we've done our first Git, we've used Vim, we're going to start adding stuff in to our Terraform script. So step 8, what we're going to do is we're going to add some variables, the provider, and then some data blocks. And I'll explain these as we go. So for this, we need to navigate to step 8 in our workbook. So we're going to be using Vim again. Make sure you're still in your project directory in Cloud Shell, right? It should say Tech Tuesday Cloud Workstation. I'm going to clear this up. Okay, so the first thing we're going to do is we're going to launch Vim to edit the main.tf file. Then we're going to put it in insert mode, hitting the I key, the letter I. And then we're going to just copy this block of code. And I'll explain this code to you here in a moment. Here what we're doing is we're declaring the variables that we defined in the tfvars file. And we even have some descriptions. And it looks like I have a typo, so I can arrow up and fix my typo. should say file there, right? And then I always like to leave a space after my last curly brackets. These are all the variables that we've defined so far. The next thing that we're going to do is we're going to specify the provider. Terraform says that a provider is essentially a plugin. And since we're using the AWS provider, that tells Terraform how to interact with the AWS APIs. There is a provider for Azure and for Google Cloud Platform and a variety of other services. But we're going to use the AWS provider. Also note that we're now starting to use some of the variables that we just got done declaring and had previously defined. We're only going to use 3 of them at this point. Later in our code, we're going to use the 4th one, the AWS PEM. So we got the provider in there. Now the next thing we're going to do is paste in some data blocks. This data block is going to let the code know what our public IP address is. I don't know if you've ever used icanhaszip.com, but let me just copy that and paste it into a new tab so you can see what data it returns. It returns an IP version 4 IP address, and that is my public IP address. So now you know how to hack me, right? Don't worry, I have firewalls in place. I've been trained by SANS. Okay, so that is what will be returned by the data. Okay. The next thing that we're going to do is we're going to add in a data block, which will tell it about all the different AWS availability zones. Again, I'm just putting an extra carriage return between these different data blocks just to make it look a little bit more readable. And the next thing we're going to do is we're going to use a data block to get the latest Ubuntu server AMI. And you're probably thinking, well, Ken, how would I know to do this? Well, what you can do is you can just Google this. And I always like to put Terraform on the beginning. And if I look down far enough, I will see, here we go, a resource from HashiCorp. Basic example using AMI lookup, right? Most recent true, here's the image. We're using version 20.04. And what is this owners all about? That is the AWS account that published it, and that belongs to Canonical. So what I did was I just put a version of that code excerpt in there. All right, see if there's anything else that we needed to do. Okay, the last thing I need to do is save my changes, right? So escape to get out of insert mode, :WQ to save it. All right. Okay, now things will start getting even more interesting. What we're going to do is we're going to run Terraform init, and then we're going to add stuff to a get ignore, and I'll explain what a get ignore is. When we type a ls in our Cloud Shell, we'll see we're going to do a ls-als. ls-als. I got to type it right. -als. There we go. Okay, so here is all of our files. The ones with the period in front are, of course, hidden. The next thing that we're going to do is we're going to initialize Terraform in this directory. You have to do it inside each project directory. We do that by typing Terraform init. So what it's doing is it's downloading the plugins that we told it about in our script. So it's downloading the plugin for AWS as an example. So notice the files that are currently there, and then that's the before. And then if I run another ALS, we'll notice that we now have a couple new files. We have this directory, and we also have this terraform.lock.hcl. Oh, we'll also run Terraform plan. So Terraform plan, we'll see if there's any changes that it needs to push out. Let's do another ALS. Okay, yeah, so nothing really changed. Let's do a git status to see which commands are, or which files are currently untracked. So git status. So we have our main TF, which of course we know should be untracked because we made modifications to it. We have a Terraform directory in the terraform.lock.hcl. So let's add the two files that we know we want to keep. Add the main TF and the Terraform lock. Paste those in. Now let's do another git status. Right, so it shows that two are staged and one is, or one whole directory is still untracked. Now what we're going to do is we're going to add this whole directory to a file called the gitignore. Guess what the gitignore file does? It tells Git to ignore anything that matches that regular expression. We're going to use vim gitignore, and then we're going to add that file to it. So the file we want is .terraform, TERRAFORM / escape WQ, and then let's do a cat just to make sure that it looks as we expect. One time while I was practicing this, and I actually had a space before the period, and it didn't work properly. All right, now if we do a git status, we will notice that we have an untracked file of gitignore, but that whole Terraform directory is gone. So now let's add that gitignore. Git add .git ignore. Git status to check it. All right, everything looks good. So now we can do our git commit. Here's our commit message, partial of main TF. Whoop. And then we do the git push origin main. Provide our credentials. Now, some of you might wonder, well, why did we commit the .terraform.lock.hcl when we didn't commit the .terraform subdirectory? Well, the purpose of the terraform.lock.hcl is Terraform figures out which dependencies it needs, and it keeps that in that lock file. So according to their documentation, you should put that in your version control repository, so that way, if that file changes, you can detect it and you can discuss it. So that's considered to be a best practice. So we wanted to follow that best practice. Okay, so now what we're going to do is we're going to add in some VPC resources. What we're going to do is we're going to open up the main TF and Vim again. Then we're going to add in this block of code. To the bottom. All right, so I'm already at the bottom, but I'm not in insert mode. Hit I, and we'll see at the very bottom it changes to insert. Now let's grab that chunk of code. Here we're starting to add in what is called resources. Okay, so what did we do? What we did was we added in from VPC on down. All right, so we defined a resource which was a type of AWS VPC. We gave it a name called Work VPC. Then we had to provide some required parameters such as the CIDR block, and we wanted to say we wanted DNS support and host names and so forth. Default tenancy. These are all different settings of a VPC, which, by the way, if you've not worked with VPCs, I have a hyperlink to a tutorial in AWS. So if any of this sounds foreign to you, definitely check out that tutorial. The next thing that we did was we created a subnet within inside that virtual private cloud. We gave it the name Work Subnet. Notice that the type of resource is called AWS Subnet. So by the way, you can do a Google search on any of these and you can get Terraform's documentation. We added an internet gateway, we added a route table, and then we added some routes in that route table and created an association to our subnet. So that's what we did in the VPC step. See if there's anything that else. Okay, so we closed Vim. And now the next thing that we're going to do is we're going to run Terraform Validate. Running Terraform Validate, we'll see if we made any typos or any obvious mistakes. It won't catch everything. Some stuff doesn't get caught until you run Terraform plan. But it said the configuration is valid, so that should be good. So it was validated, and since it's validated, oh, by the way, we don't need to run Terraform init again, but now what we're going to do is we're going to run Terraform apply. What that's going to do is it's going to push the changes out to our AWS account that we configured in the TF vars file. So Terraform apply, and now Terraform is going, and by the way, older versions required you to run the TF plan, Terraform plan before you ran apply. Just type yes. Notice how it doesn't know the IDs of some of this stuff until it actually does the apply. Oh, as I was saying, older versions of Terraform required you to run a plan and save that plan to a file, and then when you ran the Terraform apply, you'd have to specify that Terraform plan file so that would know what to provision. They've realized that that was an unnecessary set of steps. Okay, so what's it say? 5 resources added, 0 changed, 0 destroyed, and our colorized text. So now if I go into my VPC service, we should see this resource. So I see I have 2 VPCs, and the stuff that we just created was called Work VPC. And we can see it's got the CIDR block that we assigned to it. And we should also see an internet gateway was created, one called Work IGW, and subnets. The one work subnet was created. So that was we can see visually that those resources were provisioned by the script that we just ran by running that Terraform apply command. Okay, and then the next thing that we need to do is save our work, right? So first thing we're going to do is do git status. See what changes we need to save. Okay, so we have a untracked file called terraform.tfstate and then our main TF. Now, we do not want to put our TF state into source code, but that does, in like a production environment, you definitely do want to back it up because that says the exact IDs of all the different assets that were deployed. And the reason we don't want to put it in a source code repository is because if somebody else deploys your code, it would confuse AWS and Terraform saying, I'm showing that these resources are deployed, but it looks like they belong to somebody else's account. So what we're going to do is we're going to add TF state to the get ignore, and we're going to add main to our, we're going to stage and commit it. So let's do this one at a time. The first thing that we're going to do is I'm going to add both of these files to get ignore, because a backup will be made as well. So I'm going to go vim.getIgnore, and then go into insert mode and make sure I'm at the end of the line, hit carriage return, and then I'm going to paste. And that looks good. Escape WQ. Okay, so now if I go get status, that I just need to add those. So let's do a get add, GIT ADD*. Then if I do a get status, hey, wait, the get ignore didn't get included with the get asterisk because the hidden file doesn't go with it. So I go get add, and then just type the first few letters, .giti tab. There we go. Now if I go get status, I should see everything properly staged up. That's good. Now let's get our commit message. Our commit message is added VPC to the main TF. Copy that, paste that into the Cloud Shell. And then we're going to do the get push origin main. The main branch used to be called the master branch, and that has slavery connotations. And if you think about it, main just makes more sense for a master branch than master. Okay, so now I need to provide my credential. Oh, let's try that again. All right. The next thing that we're going to do is we're going to add the main security group. So when we add this main security group, we're going to basically do the same process, but now we're just going to add in additional resources. This is step 11. We're going to go in and edit the main.tf using vim. Okay, and enter insert mode, hitting I, copy this block code, and then paste that into our Cloud Shell. Okay, so this is adding resources for the security group. So the first thing that it's doing is it's creating the security group itself, which is going to be called WorkSG. We need to say who the parent of it is. So there's the VPC ID of the VPC, that's its parent. Then we're adding an ingress rule. And look at this, we're using that HTTP my IP, right? So, but what Chomp is doing is it's removing any carriage returns. And then we're tacking on /32 to the end of it, which is what we need to have a properly specified CIDR block. We're doing the same thing for the security group for RDP. Notice RDP is using port 3389, whereas our SSH rule is using port 22. And then we're allowing all out. Okay, so I need to save my work, and then we're going to do Terraform validate. Escape WQ, :WQ. And then Terraform. Oh, looks like I have an issue. So what we're saying is that there is a unsupported block type. Oh, look at, I think I have a spelling issue. So if I scroll up, yeah, look at, I forgot the R. That's why we run the validate command. So let's rerun Vim. And I'm going to come down here, type in my R. I'm going to insert mode R. I'm in replace mode. All right, insert mode. Escape, insert mode. There we go. RESOURCE. Take a running start at it. There we go. Now, :WQ. Okay. Terraform validate again. Now it's happy. Okay, so we're going to push that out to our environment using Terraform apply. Got to say yes, I do want to make those changes. Okay, so notice it said 4 added because there's already stuff out there. So it just added the security group and then those 3 security group rules. Okay, the next thing that we need to do is change or add our changes. So git add and then git commit with this commit message. Paste in my git commit message. And then let's do the git push origin main. And then let's admire our work in our Git repo. All right, so I'm gonna hit refresh. And then if we, oh, so there's our commit message. So let's go in there. Oh, let's look at the commit. So the green stuff is what's added. And we can see that there was stuff on top. Similarly, if I come out here and go to main, that is the entire file. By the way, when you're in Git, if you didn't notice, you can go raw and you can see the raw code as well. We're going to leverage that concept a little bit later in this workshop. All right, now what we're going to do is we're going to add in our Ubuntu instance. We're doing this as part of step 12 in our workbook. We're editing main TF using Vim again. So while I'm here, I'm going to copy this entire code block. Bop over to Cloud Shell, Vim, main, tab. Okay, and this time I need to make sure I'm all the way down to the bottom, that I'm in insert mode, hit I, paste. So now what we're saying is we're adding a resource called, it's a resource type called AWS_instance. We're giving it the name workstation1. Notice that I'm launching a T3 extra large. Well, we want to give our system a certain amount of horsepower. By the way, this will cost you 16 cents per hour. You feel free to change it to a lower one. I've got the list of them down here. So what you can do is you can open this and it'll give you a list of all the different instance types. And there truly is a lot of them. I would suggest you probably stay in the general purpose family. So, but again, 30 cents for 2 hours won't kill you if you decide to go that route and keep it. The nice thing is it will boot up faster. It'll run the install script faster because it's given it ample resources. The next thing that we're doing is we're outputting some data just simply for our convenience. One of the things that we're going to output is the connection string, the RDP address, and the username and the password for the RDP. But because it's locked down so that it can only be accessed from our IP address, you don't need to worry about one of your neighbors hacking you. You will still want to change the password. However, you won't be able to RDP yet because we haven't added that service, but you will be able to SSH in as part of this exercise. I'm going to escape to get out of the insert mode, WQ. All right. The next thing that I'm going to do is run Terraform validate. Uh-oh, I'm getting an error. Because I'm referencing a variable that hasn't been defined yet, SSH key has not been declared. This was on purpose because I want to show you the troubleshooting process. So what we're going to do now is we're going to go in and add those. So we're going to open up main TF and add that in as a variable. And I'm going to add that in below my other variables. How about right there? Insert mode, character return, and then paste. Escape, WQ. Now we also need to modify our terraform.tfvars. The validate won't catch it, but it'll ask for us to provide it via the command line, which we won't. We want it in here. So insert mode, and then let's grab our snippet of code to add in, which is just SSH key equals cloud workstation. And save it. All right. Now, when we run Terraform validate, it should be happy. Oh, it isn't happy because it's referencing a startup script that we have not yet provided. So we're going to do that as well. We're going to make a really simple one to start with. We're going to use echo rather than vim this time to create it. We're just going to echo bang bin bash and date into workstation 1. Great. Okay, now when we run Terraform, it should be happy, and then we'll run Terraform apply. Passes validation. Now let's run Terraform apply. Yes, we do want to push it out there. Now EC2 instances take a little bit of time to spin up. Good. So now we can SSH into it. So what we're going to do is we're going to copy this SSH connection string. Then we're going to open up a new tab. So here we can see we have one tab. So go to Actions and then go New Tab. There we go. And the reason why we want to be in this, we want to open up a new tab, is because we're going to paste in this. And there we go. And yes, I do want to connect. So now we have logged into our Ubuntu instance, but it's just a real basic Ubuntu instance at this point. And then we're going to flip back to our other one and we're going to commit this. So git add asterisk. Oh, I'm in the wrong directory. Or I'm going to close this one. And now I'm in the right place. Git add asterisk. I'm going to do git status just to take a look. Okay, so we got a bunch of new stuff getting added. Well, 2 changes in 1 new file. And then we're going to do the git commit. Then git push origin main. And let's go admire our work. Hit refresh. Okay, there we can see our new changes and our commit message. We added our Ubuntu instance, so the next step is we're going to customize the EC2 instance. And this is step 13. So as part of step 13, what we're going to do is we're going to add a whole bunch of code to that workstation1.sh. But first, I want to cover user data a little bit. So user data is a script that gets ran at boot time. Now we can look at that on the host. So what I'm going to do is I'm going to SSH back into the host. By the way, I'm going to clear my screen here. If I go Terraform output, that will give me the outputs of the last time Terraform was ran. And here is my SSH connection string. And I'm going to open up a new tab, which is typically what I do for doing an SSH session. And if I go ls, you'll see that there's my PEM, and I'm going to paste in the SSH connection string, which is actually giving the full path to it. And now I'm in. Okay, so what we're doing as part of this is we're just doing a little bit of poking around. So the first thing we're going to do is we're going to use sudo to elevate our privileges and to take a look at the user-data.txt file on the host. So this should look familiar, right? That is our user data file so far. Now there's another way we can do it. We can get it using the metadata service. This is a really long command, and it's one that I just keep in a notepad so that way I have it if ever I'm curious. And here it's making a call, but then what we get as part of the response body is the command. Okay, what's next? The next thing that we're going to do is we're now going to modify this workstation 1. We're going to open Vim, W-O-R-K tab. There we go. And now I'm teaching you a Vim can. Arrow down to the bottom row and type DD. That will blow away the date. Now we're going to go in insert mode. Hit N to go to the end of the line, carriage return, and then here is where we're going to paste stuff in. We need to make sure that the bang bin bash is left in place. Now, copy all of this code. As an exercise after this lab, I challenge you to study the code and see everything that is going on here. I'm going to paste that in. Then hit escape, WQ. Now the next thing I want you to do is just run head, instead of Vim, run head. And what we want to do is just make sure that that bin bash is still in there. Okay, and it is. Because if that's not in there, the script won't run, and you'll be like, why isn't my configuration happening? Okay, so the next thing we're going to do is Terraform validate and Terraform apply. Terraform validate will not look at the entire contents of that workstation1.sh. It's just looking at Terraform related stuff. All right, and now let's do a Terraform apply. And then I'm going to hit yes. And it's what's going to do, notice it's destroying the workstation. The reason is because since the script has to run at boot time, it's tearing it down. It's going to spin up another one. All right, so now we have a new SSH string and a new IP address. So I'm going to open up a new tab, paste that in. Yes, I want to connect. All right, so now what we're going to do is we're going to watch this thing work. So we're going to run this tail-f. -f says follow the particular log file. So I'm going to copy that, paste that into my second tab of my Cloud Shell. Then when I hit that, we can see that it's doing updates and installation of packages and so forth. And then when it's done, we'll get a message whether or not we're doing this tail follow. It uses Mate as the desktop manager, so we're now in the process of installing that. Then after that, it will install Chrome, Firefox, and Python. Almost there. This is why I gave it a pretty hefty instance type, is so that it would be able to process through this fairly fast. Okay, it looks like it's installing Python now. Okay, so here's the message. First boot has completed. All right, so now when we see that, we should be able to RDP in. And here is our username and our password. And this is the RDP address we're going to use. So if I click this, and then if I click on, to launch your remote desktop, just hit start, run on Windows, and then MSTSC, Microsoft Terminal Services Client. Now I just need to replace that address with the one in my clipboard, right, from there. Then if I click connect, and it looks like it's not getting anywhere, of course. Think about this. I've RDPing from my desktop, but what about our security group rules? So it looks like we need to make a little bit of a change. So what we're going to do is we're going to add another variable in with an alternate RDP source. So that's kind of my workaround. Because I wrote this originally because I always would deploy Terraform from my own desktop. But since we're using Cloud Shell, so we all have a unified experience, we now need to make some modifications. So we're going to do vim on main TF. We're going to add in a variable. So there's my variable. And then the next thing that I need to do is cursor down to where my security group is defined, and I'm going to add in a new security group rule. Yeah, right there. So SSH RDP, and I want to put it right about here. And then I'm going to grab my code. Paste that in. Escape, :WQ. Now, the other thing I need to do is add in a TF-vars for it. Alt RDP source. But now I need to make a modification because we don't want it to come from this address. I need it to come from my IP address. So I'm going to go click in my ICANN has IP. So I'm going to copy this, and then I'm going to add that into my Cloud Shell right where the cursor is. And make sure you have the /32 left in there. Okay? Escape WQ. Now, Terraform. Validate. Terraform's happy, so Terraform, apply. Yes, and the nice thing is this one happens very fast because the IP address doesn't change. It just is modifying that security group rule. Oh, looks like I have a mistake. So I think it's in my TFRs. Okay. Missing a character. Insert A. WQ, save it. Now, when I do my Terraform apply, it should be happy. Notice how Terraform apply caught something that Terraform validate did not. So yes. Okay, so let's see if we can RDP in this time. So my IP address has not changed. Now if I click connect, yes, this is all a good sign. And okay, so what was our name? Username was student. And it was change me. Great. Okay, so now we're SSH into our EC2 instance. And we've RDP'd into our EC2 instance. So let's see if there's anything left to do on that particular step. Nope, we just want to add our changes. So here's our git commit message. Then git push origin main. All right, now if we admire our work, we can come over here and drill into main TF. There's all those changes. And we can look at our workstation 1. Here's all that content that we added. We are very close to being done, and we're very close to being at our target time. Last thing that we're going to do is we're going to finish up the documentation. And because part of what we've done is we made ourselves a security tool that we can use for remote browsing. So what we're going to do is, and this will actually take place pretty quick. Here's what we're going to do is we're going to look at the raw content from a template. So let me show you where that template is. Here's the template. So we're going to go back into our workbook. Step 14. We're going to copy this command that's going to basically make a local copy of it and rename it just readme.md. And now if we go ls, we can see, well, the README was there before, but let's go head -n19 README. Okay, so see we have some Z's in here and some X's. What we're going to do is we're going to do some kung fu magic to replace those with whatever you named your GitHub project. So we're just going to copy this. Then let's run this. And now if we do that head 19 again, we'll see that it's now been updated with whatever you called it. Here's your specific link and then the name of the project. And we also see that it's been replaced in the title. Cool. All right. And then the last thing is we're just going to add that. So we're going to update the README. Paste. And then we're going to do a git push origin main. All right, so now check this out. When we come back to our main root, we're going to see that the README is there. So this is how you can run this. So now this assumes that you have Terraform running on whichever system, right? And we talked about how to install Terraform. So you can run this even if you're not going to use the AWS Cloud Shell. As long as you can run Terraform, it should work for you. Now, our very last step, which we're not going to do, is testing, right? So no security tool is complete until you've tore it down and tested it. Well, I will show you how to tear it down though, right? So we'll come back here to our Cloud Shell, and we're going to run Terraform destroy. Notice I'm still SSH'd in, right? So we're going to see that get killed as well. Oh, do I want to do it? Yes, I do. So I type yes. So it'll start tearing everything down. See, there it shows that my RDP connection just died. This should show that it died. Yeah, connection closed by a remote host. Our Terraform is in the process of tearing down. Okay, so in our final few minutes, what I wanted to do was just give you some caveats. First of all, don't break the law, right? Follow the AWS terms of service. Why? Because remember, you're using AWS for the DNS resolution whenever you're doing surfing using Chrome or Firefox or whatever browser you installed or whatever Python or CLI commands you're using AWS for DNS resolution. So they know what you're doing. Also, you're running on their hypervisor and you're in their data centers. This does provide obfuscation from folks on the internet, but it won't protect you from AWS. So don't be a douchebag. Don't break the law. Follow their policies. Also, tear it down or turn it off when you're not using it, right? Since you're paying X amount of cents per hour, it makes sense to tear it down. But the whole purpose of using Terraform is so that we can deploy it and tear it down in just a matter of 5 minutes. So I've timed that script. It takes about 3.5 for the boot up process of the Ubuntu workstation to complete. But that's pretty good to deploy a system if we ever wanted to do remote browsing. We also want to make sure that you keep your security groups tightened down. We showed you how to do that using your own IP address. And then make sure you change that RDP password. This is brought to you by the SANS Cloud team. We have a variety of courses that have been built out in the last few years, which we're very proud of. As we mentioned, I teach SEC 545 currently and also SEC 488. So if ever I see you in public at a live in-person event, be sure to come up and introduce yourself. I always like to meet students that I've been teaching virtually.